Today on Macaulay Math, we're doing more graphs and displays. Intro. Okay, good day. I'm Professor Macaulay. This is Math 130, Intro to Statistics, lesson number 5 on other plots and displays. Our goals for the day. We are going to graph and interpretive quantitative data sets using stem and leaf plots and dot plots. We are going to graph and interpret paired data sets using scatter plots. Stem and leaf plots, dot plots, and scatter plots are tools that statisticians use to begin telling the story of a set of data. They can be used to highlight patterns in data, describe the distribution of the data, and speak about the relationships and correlations in data. These plots are what statisticians use to get started when analyzing data. So, let's get started. Okay, let's start with a definition. A stem and leaf plot is an example of an exploratory data analysis, an EDA, where each number is separated into a stem, which is the leftmost digit, so the tens digits are going to be the stems, and a leaf, which is the rightmost digit, and there should be as many leaves as entries for the leftmost digit. And what that means is that if you have duplicate numbers, then you should write both of those repeated sets of data. Additionally, the leaves should be reordered from least to greatest. So a simple example, we'll do one right here. First example, we'll draw a line right here, and then on this left-hand side, we're going to put the tens digits, and then on this side, we'll put the ones digits. And so I'm going to first look for the smallest value. There's a 5 or a 53, and I don't see anything lower than a 50, and the highest number I see is 91. So I'll go 5, and then I'll go 6, and then I'll go 7, and then I'll go 8, and then I'll go 9. And then we will just go through and cross off these numbers and write the ones digits in this right hand side. So 80, I'll come down to 8, and I'll put a 0, cross that off. And so for 67, I'll come up to the 6, and then I will put a 7 there, cross that off. For 81, I'll put an 1 in the 8th row, and then for 73, we'll put a 3 there. For 53, we'll put a 3 there. For 90, we'll put a 0 there. Then for 83, I'll put a 3. And then for 91, we'll put a 1. And then for 65, we'll put a 5 there. And then for 78, I'll put an 8 there. Then for 80, we'll put another 0. And you can see I had two 80s, so I put two zeros down there. Then for 71, I need a 1. And then for 62, I need another 2. And this is how I'm going to separate the data. But as this last sentence says, the leaves should be reordered from least to greatest. So for my final answer, I'll make another data table. I'll go 5, 6, 7, 8, and then 9. And since 53 was the only 50 number, I'll put a 3 there. This one is completely out of order. We'll change it to 2, 5, 7. This one has to go 1, 3, 8. This one here has 2 zeros, and then a 1, and then a 3, and then this one has a 0, and then a 1. And we'll put a box around this one, and that is it.
Let's move on. So the next one, a dot plot, is a method of plotting data along a horizontal number line where each instance of data is represented vertically by a vertically stacked dot. It can be used to visualize how data are distributed and identify unusual entries. So let's do an example. The following data represent high temperatures in Newark for a 21-day period in Newark. Create a dot plot display for the data. So here's how we're going to do that. First thing we're going to do is we're going to make a number line here, and we're going to get a kind of get an idea for the range. So I'm looking through here. 70 looks like the low number. Let's see, 80. 81, 82, 83. Looks like 83 is the highest number. Wait, let's see. No, there's an 85. All right. So we'll start at 70 and we'll go from there. All right. So let's get my pen tool. We'll go 70 right there. We'll go 71, 72, 73, 74, 75, 76, 77, 78, 79, 80, 81, 82, 83, 84, and 85. So we're just going to make dots and stack them above the numbers that we have. So 78, we'll put a dot right there. 79, we'll put a dot right there. 74, we'll put a dot right there. 81, we'll put a dot right there. 85, we'll put a dot right there. 82, we'll put a dot right there. 70, put a dot right there. 76, have a dot right there. 79, well, 79's already got a dot, so we're going to stack a value vertically above that one for every time we have a repeated. And so 78, there's our first repeated for 78. 82 has a repeated value. 81 has a repeated value. Cross that out. 79, repeated value. 83, that's its first one. 82, another repeated value. 78, another repeated value. 83, repeated. 79 has its fourth dot. 81, value there, and 80, value right there. And so, and again, when we look at the definition, it says we can use this to visualize how data are distributed and identify unusual entries. And so it looks like most of the data are clustered between 76 and 83, and that this 70 might be kind of an odd day for, or an outlier, an odd number, especially when we're talking about a 28-day period in June. So there you go.
What I want to do now is I want to do that same problem, but I want to show that Desmos can do dot plots for you, and your results will be very similar. And so it will order all the points, especially if they come out of order. That'll be great for us. So I'm going to use the same set of data because there are a couple little tricks that I want to show about Desmos. So I'm going to pull up Desmos. And the first thing that we're going to want to do, usually when we set up any set of data, is we're going to start by putting that data in a table. And so I'm going to hit the little plus symbol here, and I'm going to come down, I'm going to hit table. It usually gives us an X and Y. We're not going to need X and Y, we're just going to need X's. I'm going to take that data set that I already had when we did it by hand, and I'm just going to put it back in. I have it as an open data set in another window, so I'm just going to copy from that. And so I'm going to go 78, 79, 74, 81, 85, 82, 70, 76, and then 79, and then 78, 82, 81, 79 again, 83, 82, 78, 83, 79, 81, 83, and then 80. Now, a couple of things that you can do with Desmos that'll help as you move forward. So it's very important that we get an accurate data set in. So just a real quick check: 78, 79, 74, 81, 85, 82, 70, 76, 79, 78, 82, 81, 79, 83, 82, 78, 83, 70, 81, 83, and 80 to finish it off. Okay, so we can go down here to this bottom one, and you can enter, you can have Desmos do the dot plot for you in a couple of different ways. So the first thing you can always do is you can always show the keypad and come over here to functions, and you can scroll down, and once you get down to visualizations, that's when a lot of the statistics stuff starts, and we're trying to do a dot plot here. So you can just click dot plot and it will ask for the data set. Now, the other thing that you can do is if you know what the command is, and in this case the command is dot plot, you can actually type that and you'll notice something. And so I'm just going to cancel that out, and I am just going to type dot plot. And you'll notice when I complete dot plot, that is a function in Desmos, what it will do is it'll change from that italicized text to regular text. So see how that's italicized, and it wants to consider all of these as variables. And then if I put on that T at the end, if I put the T on the end and then hit parentheses, it'll ask what data set do you want to make a dot plot out of. So if I go back up here, I put my data in X1. So I want to have my dot plot be made from the data in X1. So I'm going to hit X, and then I'm going to immediately hit a 1 after it. And when you do it in that fashion, it puts that 1 as a subscript that we're looking for. So I'm going to close the parentheses there, and I don't see any data here, and that's okay because this number right here goes up to about 15. Now what we can do is we could reorder it here by hitting the wrench feature, this graph settings, and reorder it, or we could come over here and try to do a zoom fit. Now the zoom fit doesn't always work perfectly, but let's give it a shot. And here we see that just in general we have a pretty good copy of what we had made before, and I think that looks pretty good, and we could find our mean median mode if we needed to. All right, moving on.
Paired data sets, two data sets where one data in a first set is matched to one data in a second set. And we can organize that in a scatter plot, a plot where paired data are plotted as points on a coordinate plane. So when I think about data sets where one data in the first set is matched with a second data in a second set, those things sound like X and Y values that we could plot on a scatter plot. So 10 students take a pre-test at the start of the semester of statistics. Then after the semester, students took a post-test. Their pre-post-test scores are given. Use your graphing calculator to create a scatter plot of the data.
Okay, so if we're going to do a scatter plot using Desmos, Desmos does it much easier than the old graphing calculators used to do it. In fact, it does it almost automatically if you plug in bivariate data. And what I mean by bivariate data is data that comes in ordered pairs, which is what this data set comes in. So if I take this data set and I go over to Desmos, and again, we're going to put this data in a table. So we'll hit the plus symbol and we will go table. And this time we're going to use both the X column and the Y column. And so if we look at this data set once more, I have it up in a different window. It is listed horizontally, but I'm going to put it vertically with the pretest as my X value and the post-test as my Y value. So my first ordered pair will be 5783. So we'll go back there to Desmos, and the way I'm going to do it, just for sake of ease, is I'm going to put all the X values in, and then I'll check and make sure everything lines up when I put in the Y value. So I'll go 57, and then I down arrow to go 58, then 60, then 63, then 71, then 72, then 76, then 77, then 78, and then 87. So 87 right there. All right, then we'll go back up to the top and we'll go over, using our arrow keys, over to the Y column, and the Y column is going to be our post test. So I'm going to put an 83 for that first 57. Then for the 58, I'm going to put 85. And then for the 60, I'm going to put 52. And then for the 63, I'm going to put a 69 in. Then for the 71, I'm going to put a 58 in. And then for the 72, I'm going to hit 78. And then for the 76, I'm going to go 87. Then for the 77, I'm going to go 79. Then for the 78, I'm going to go 62. And then for the 87, I'm going to go 67. All right. Now, again, if you put in ordered pair data, bivariate data, into Desmos, it will automatically give you a scatter plot. And again, we don't see any scatter plot data here because none of the data falls from -10 to +10 on the x-axis or from -5 to +5 on the y-axis. So we could hit this little wrench symbol and make the data ourselves, or we could come down here to this little zoom fit and see if that at least gets us started. And that looks like it gets all of the data in there because it goes from 40 to 100 on both the x and the y axis. And I don't think there's anything that is less than 40 or greater than 100 on either of those axes. Now, if I'm looking at this data, I'm probably saying there's not a whole lot of correlation going on, but that is for a different lesson.
All right, so the last thing I want to talk about a little bit about is some bad graphs. Bad graphs is a graph that is poorly labeled or purposely misleading. So let's look at, I did a screen capture from the internet here, and I retrieved this from Statistic How To, Data Central, Bush tax cuts. So this is not my picture. I pulled it from the internet, giving credit. But outside of my personal bias against Fox News, why is this a poorly constructed graph? Well, if you look at it here at the bottom, this is not 0. This is 34. And so this particular graph makes it look like after January 1st, 2013, that your top tax rate was going to pretty much quadruple, even though it really only went from 35% to 39.6%. This graph is purposely misleading. A more unbiased graph might look something a little bit more like this, and clearly we can see that if I match this as 35% and this is 39.6%, there is clearly a lot less difference shown between these two percentage tax rates, and that's not degrees. I see that now. We should put percent there. That's clearly different than what we saw on this previous graph. So bad graphs, y'all, whenever you're looking at your graphs, please look at them with a critical eye and see if there's any implicit bias in them. And so other poor graphs, pictographs that distort area or volume. Pictographs, I don't care for pictographs anywhere. Circle graphs can also be misleading for the same reason. Graphs with axes that are poorly labeled, and again, we have one that's poorly labeled right here. And then cluttered graphs can distract the reader, so we want to make sure that our graphs are as clear as possible. Well, that's all I got for this lesson today, folks. So, the Marvel fun fact of the day. In preparing for Guardians of the Galaxy, Chris Pratt and Zoe Saldana used protective padding so that they could actually hit each other, but on the actual day of filming, Pratt forgot to wear his protective gear and was kicked so hard that he had a bruise on his ribs for the remainder of filming. Well, again, that's all I got today, folks. Have a good day. Bye.